In Chapter 4, we're going to talk about reactions in aqueous solution. These are solutions where you have some type of matter dissolved in water. A solution in which water is the dissolving medium, your solvent, is called an aqueous solution. Water is probably the most common solvent that we'll talk about this semester. Water dissolves many ionic compounds, and we can study the properties of ions in solution. And we're going to discuss electrolytes, precipitation reactions, and solubility, net ionic equations as well. We'll also take a look at acid-base reactions, and finally oxidation reduction reactions. And all of this is going to come together, and we can apply these concepts to solution concentration and solution stoichiometry. Solutions. Solutions are a type of mixture, specifically a homogeneous mixture, of two or more substances. So if you remember from chapter 1 that a homogeneous mixture is the same throughout. A solution is composed of a solvent and a solute. The solvent is the substance in greater abundance, and the solute is a component in a mixture in a lesser extent. An example, let's say we have some salt water. We're going to do some cooking. So we get a big pot out and put 4 cups of water in the pot, along with a pinch of salt. Well, the salt water is the solution. Water is the solvent, and the salt is the solute. When water is the solvent, we give it a special name. We call solutions in which water is the solvent an aqueous solution. You'll find most of the solutions we talk about in chemistry are aqueous solutions. We can have more than one solute in a solution. Take, for example, some soda. The solvent is water, but there are many solutes. We have the sugar is a solute, the caffeine is also a solute, the caramel color, citric acid, also solutes, and these other ingredients are also solutes. Substances dissolve in water in different ways depending on the type of substance. Ionic compounds dissolve in water by dissociation, where water molecules surround the separated cations and anions. Where molecular compounds, on the other hand, do not dissociate in water. They're dissolved by what we call solvation. So the water molecule surrounds the molecular compound. No bonds break apart unless there's a chemical reaction. Some molecular substance will react with water, but we're not going to focus on those just yet. Electrolytes are defined as compounds that form ions when dissolved in water. The resulting solutions conduct electricity. So when we dissolve an electrolyte to form these solutions, we have ions that are formed. And these ions facilitate the flow of electrons. On the other hand, non-electrolytes do not conduct electricity. These are substances that may dissolve in water, but does not dissociate into ions. We can further classify electrolytes into strong and weak electrolytes. So your strong electrolytes are your ionic compounds. And we'll talk more about weak electrolytes in a minute. But weak electrolytes conduct electricity, but not quite as well as strong electrolytes. And non-electrolytes don't conduct electricity. Let's talk a little bit about the term strength as it relates to chemistry. Okay, so when I'm talking about strength, I'm not talking about powerful strength, like Kai Green right here. Okay, so when I'm describing strength as a descriptor of electrolytes, I'm talking about the substance's ability to dissociate. So when I'm describing a strong electrolyte, what I mean is that the substance I'm talking about dissociates completely into ions. When I'm describing a weak electrolyte, I'm saying that the substance does dissociate in water, but only a little bit. Okay. So we have the example here next to Chi. This is a strong acid, hydrochloric acid. When this is dissolved in water, it dissociates completely to form hydrogen plus cations and chloride minus anions. If we were able to see the ions under a microscope, we would see that nearly 100% of ions would be separated by water molecules. Now, weak electrolytes like acetic acid, this is a weak electrolyte, they only dissociate into a small portion of ions. So for acetic acid, this would dissociate a little bit into the acetate ion and the hydrogen ion. So if we were to take a look at the molecules and ions formed from the dissociation of acetic acid in water, we would find that most of our sample is acetic acid. Only about 1% of the sample would be the acetate ion and the hydrogen ion. So let's take a look at this arrow, okay? It's a little bit of a funny looking arrow, and this is called an equilibrium arrow. So where one arrow is a little bit shorter than the other, and one's going in the forward direction and the other is going in the reverse reaction. And what it is telling us is this reaction is a reversible reaction. And notice how I have one end of the arrow a little bit longer. That tells us that the reactant side of the equilibrium is favored. Let's recap about the term strong as it relates to chemistry. It means complete dissociation, not powerful. And weak means only partial dissociation. It does not relate to having less power. Let's take a look at some examples how ionic compounds dissociate in water. Okay, we have sodium chloride, for example, solid sodium chloride, and we dissolve this in water. It's going to dissociate into sodium cations and chloride anions. The sodium chloride is the solute and water is the solvent. We generated ions in solution upon dissolving sodium chloride in water, so this is an electrolyte. If we were to test the conductivity of this mixture, we would find out that yes, it does indeed conduct electricity. Next example is copper to chloride. In this case, we dissociate into copper 2 plus, and we form 2 chloride minus anions. Okay, and let's just remember that non-electrolytes are compounds that do not dissociate in water. These are molecular compounds composed of just nonmetals, like glucose or methane or carbon dioxide. These are non-electrolytes and they do not dissociate in water. There are some exceptions, and these are called acids and bases. If we have a strong acid or a strong base, these will also be strong electrolytes and dissociate completely in water. If we have a weak acid or a weak base, these just dissociate a little bit, and these will be weak electrolytes. An acid is a substance that produces H+ ions when dissolved in water. And there are various definitions of acids, but this is the one that we'll use for this unit. Like we discussed in the previous slide, there are strong acids and there are weak acids. Okay, and the properties in solution are going to be a bit different for weak acids and strong acids. Go through this list of our strong acids, okay, or the strong acids that we'll talk about in this course. We have hydroiodic acid, hydrobromic acid, perchloric acid, hydrochloric acid, chloric acid, sulfuric acid, and nitric acid. These are the 7 strong acids that you need to commit to memory, okay? So the key difference between strong acids and weak acids is that the strong acid dissociates into ions in water. Weak acids form a chemical equilibrium, and we'll talk a bit more about weak acids in the future. And remember, when I'm talking about acid strength, we're not talking about power. We're talking about the acid's ability to dissociate into ions. Okay, and also on this slide, not only do I give you the 7 strong acids, but I show how these 7 strong acids dissociate into ions. First, we have the hydrogen hydroiodic acid, and when it's dissolved in water, it dissociates into hydrogen ions and iodide ions. By knowing all of these strong acids, you'll be able to identify the weak acids because all other acids, for the most part anyway, are weak. Most of the weak acids we'll talk about start with an H in the formula. For example, HCN, or hydrocyanic acid, and HF, hydrofluoric acid. Those are weak acids, okay? So remember that these weak acids partially dissociate into water. In addition to acids, we have bases. A base is a substance that produces OH- ions in aqueous solution, or they accept an H+. Okay, and typically these can be recognized because the formula ends in OH. Okay, the strong bases are all the group 1 hydroxides: sodium hydroxide, potassium hydroxide, lithium hydroxide, rubidium hydroxide, and cesium hydroxide. And the heavy group 2 hydroxides. And those are calcium hydroxide, strontium hydroxide, and barium hydroxide. Just like strong acids, strong bases fully dissociate in water. So if I dissolve sodium hydroxide in water, it will fully dissociate into sodium plus cations and hydroxide minus anions. And remember that strong bases are strong electrolytes. Weak bases will have partial dissociation in solution. An example of a weak base is ammonia. Ammonia has a formula of NH3, and we dissolve this in water and it's going to form an equilibrium with the ammonium plus ion and the hydroxide minus ion. And weak bases are weak electrolytes.